In this video, I'll be making a simple binary clock in JavaScript. I'm going to be recording the whole process, playing it back in fast forward mode, and at the end, I'll go through the code line by line explaining what I've done. So let's go ahead and get started. Okay, so basically this is a working binary clock now. What I've done is I've started off by creating a simple wrapper container called clock, or a wrapper div called clock. Let me open up the CSS, or the HTML rather. So it's basically a wrapper div with an ID of clock that holds these 6 columns, the H1, H2, M1, M2, S1, S2. So it's for hour, minute, and second. And then for each of these columns, I have a series of dots. So for this very first number, you're only ever going to have a 0, a 1, or a 2 for the 24-hour period. And then for the second row, you have 4 because the highest number you need to represent in that second spot is a 9 for 1900 hours. And then same thing for the minutes and the seconds. So for the third column, you only have to represent up to 5, which is basically the top dot and the bottom dot. Because the way it works is 1, 2, this is 1, 2, 4, and 8. So if we save that, let's change this color real quick from that to just a light gray color, or light off-white. So this is the 1 placeholder, 2 placeholder, 4 placeholder, and 8. So right now it's 4 plus 1, so 5. So 1, 5, 3, 4. So 1534 or 334. And then the last 2 are seconds. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Alright, so we have this recursive function. It could also be written as function n, and this is just shorthand, fat arrows, ES6 style that I'm transitioning to. So what we're going to do is when we first come in here, document ready, that's basically going to say fire all this when the page is fully loaded and everything's ready to go. So we create this X variable, and this X variable is going to have multiple patterns stored, and the patterns are going to be referenced by the number, either 0 through 10 or the 0 through 9. So if we want to find what pattern we should be using for 3, it would just be x3, right? Because you have x, the 3 here is going to give us this. So x3 is equal to that. So if we wanted a 3, we would need on, off, off. So it'd be on, off, off. So right now this column is the minutes section. So it's 1 and 4, so it's a 5. So if we look at the 5, now it's 6, we'll look at the 6. And we call X, we pass in a 6, and we get this array, which is off, on, off. So off, on, off. So that's how I've set up this pattern system. So all we have to do is get the current number for each one of these columns or indexes. So if we treat each index here as if it were assigned to each column, we have 6 indexes, and we have 6 columns. So this will be mapped to the first column, and this one the second column. So all we have to do is, if we call t0 equals 2, right? So if we get x2 is equal to that. So we know t0 is equal to off, on, off, off. So what we need to do is we need to get to that first column, and we need to find all the dots in it, or these individual placeholders. And we do that by, we get the first column here, we get the first level divs, and then we loop through those one at a time. So the first time through, this I is going to be 1 or 0, and it's going to be the first div in V. So we're grabbing that first div and we're telling it to find all the dot classes inside of it. And then we want to loop through each of those, and then we'll pass the index and dot into this function. And then that dot is going to start off 0, 1, and then the next time comes through, this will be 1, and then it'll be 0, 1, 2, 3, and so on and so forth. So when we get here, we'll say this is 0, and this will be the first dot we find, which will be this one here. And we check, and we want to set the CSS background color, and we want to check to see if this pattern is equal to 0 or 1. So like we did up here, T0, we see that's a 2, and then we go and we grab a 2. So in this case, we check TI, right? Because we're in the first item here, the first column. So say that's a 0, right? So T0, and in this case, we'll just say it's a 2. So we'll just simplify that to a 2. And now X2 is this array here, right? So we could simplify that into this array. And all we're doing is passing the index of each dot we find in this column. So the first time through it's going to be 0, second time it's going to be 1. So the first time through, we're going to see here, this is going to be 0 for the first time through. So the first item here is going to be 0. So this gets basically set to 0, right? So if 0 equals 0, then return white, otherwise turn this E color. Now, the second time through, this is going to be 0, but this will be 1. So this will change to a 1. Now, the second index, or the second item, index 1, is a 1. So 1 equals 0 is false. So we set it to the on state. So that's what this code is for. It's just a way to reference back into these patterns and figure out if this number needs to be a 0 or a 1, or off or on. And that's all there is to it. We have the interval. So when we first come in here, we're setting T to current time, right? Because we're grabbing the new date and we're splitting that date. Here, let's open up Node. And we'll do new date. That creates that string, or date object. We'll go to string. That gives us a string that we could split at the spaces, which gives us an array of strings. And we are interested in the fourth item in that array, which is the time. We're not interested in those colons, so we'll replace them. Now we have just the hours, minutes, and seconds, but we want that in an array form. So we'll split that. But now it's an array of strings. We want them to be digits or numbers. So we can map and return. You could do parse int, or you can do parse float, or what I've chosen, double tilde, same thing. So now we have that array of integers that we can call. So if we set, let's say, let x, let's see if I already set t. All right, so t is now equal to that. So if we call t5, that's calling the last number. So if we see here, it's a 9. So if we go t5 plus plus, and we'll look at t, now it's a 10. Now the problem is that 10 is wrong, because if we do t.join, now it's 1500 hours, 41 minutes, and 10 seconds. No, that's wrong. So this needs to be reset to 0, and this needs to be incremented to 6. So it'd be t5 equals 0, t4 equals 6, right? So now if we look at, there we go. Now we have 1500 hours, 41 minutes, and 60 seconds. Well, that's not right, because 60 needs to actually be carried over to the next minute. So we have to reset the 6 to a 0, and we need to increment the minute. So now if we take a look at tjoin, now we've incremented from 41 minutes to 42 minutes and 0 seconds. So all we have to do is we have to increment this 5th item every 1 second. So we grab it when the script first loads, and then every 1 second it's going to add 1 second to this here. And then we have to recursively check to see, has this hit a maximum number? If it has, reset it and increment the one to the left of it. So that's what this recursive call right here is. So this increment function takes a variable n, and then it just increments n. So the first time we call it, we're going to call t5, right? So this t5, as we call it right here, t9 becomes 10, and you might notice something. We'll go up here. So this 9 plus 1, right? That becomes 10. So that becomes 10 here. So we reset it to 0, but this becomes 6. Well, 60 needs to be reset to 0 because that was 60. And then this gets set to 10. Oh, 10, right? We reset that to 0, and we change that to 6. Okay, well, that needs to be reset to 0, and this needs to be incremented, right? So you see a pattern 610, 610, and it repeats. So that's basically what we can tell is, you know, if the placeholder, if we go 0, 1, 2, 3, 4, 5, right? And we go, this is 10, this is 6, this is 10, this is 6, this is 10. And the spacing is going to get a little screwy, but you can see it's just a flip-flop. So you could create a variable, a boolean, to flip-flop that, or you can do some math and just say, okay, well, we're working with the column 5 or index 5. Does 5 equally divide by 2? Is it even or odd, right? So if it's even, then you make it this number. If it's odd, make it that number. So that's what this is. So n mod 2 equals 1 is saying if 5 divided by 2 has a remainder of 1, because that's what modulus is it returns the remainder after you divide by a number. If it is equal to 1, then we'll make the maximum or the reset number 10. If, say, it's a 4 that we pass in here, 4 divided by 2 has a remainder of 0, so it's set to 6. And then if we pass in a 3, 3 divided by 2 has a remainder of 1, so it's set to 10. So that's how we take care of this little flip-flop. So the first time through, T5 here, first time through, this is going to increment that number. And let's just pretend it was a 9. So we call increment on T5, that becomes a 10. So now if T5, which is now a 10, and this is a 5, right? 5 divided by 2 has a remainder of 1. So this becomes a 10, right? So if 10 equals 10, we reset it to 0. And then now that this has incremented to 10, we reset it to 0. Now n is equal to 5, because that's what we passed in by calling increment 5. We want to check to make sure we're not, all the way to the first item here. So we want to say if n, so if 1, if 2, if 3, 4, or 5, because if 0 won't run. So if 5 increment minus n. So minus reduces the variable before it's used. So we're gonna pass in a 5, and if the n or minus n will make it a 4. So it'll increment 4, right? All right, so now we've called increment 4. So increment 4 would take the next number and check to make sure that it hasn't reached the maximum, reset. So it does that recursively all the way up. Now, when you get to this special case of 23, 59, 59, we never want to be at 240001, right? Because that is actually 000001, or 1 second into the new day. So that's a special case we have to check for, because once we get here and we add +1 to this, that becomes 10, that becomes a 6, that becomes 0, this becomes 10, this becomes a 6, that becomes 0, this becomes a 4. Now there is no testing to see, if we're at the second index, or the second item, and if it's a 4, because we're just checking for 10 or 6, right? So down here is where we check to see if we've reached this number here. So all we do is we join these together. So t.join gives us a string, and then all we're doing is checking to see if it's 240,000, and if so, we have array 6.fill0, which basically gives us an array of 6 zeros, which is basically stuffed back into t. It's just a cleaner way of saying t0 equals 0, t1 equals 0, or t equals 1, 2, 3, 4, 5, 6 dot split, which makes it an array of integers dot map I return parse int I, or something like that, right? It's like, why do all of this when array 6 dot fill0 will take care of it, right? So now we've checked to see if we've reached midnight, and if we have, then we've reset just to 0000000, right? So now our t is equal to current time, because we've +1 on the second position every 1 second, right? So we're going into these divs. Let me go back and put a border on this. Border solid 1 pixel red. All right, and we can space it out. Margin 10 pixels. All right. So now you see I have 6 red columns. These are the first level divs. The H1, H2, M1, M2, S1, S2. So that's what this each is for. This each is looping through these columns because it's getting just those first level divs. Now it's passing the index, which is going to be 0 the first time, so on and so forth, and it's passing the reference to the individual divs in the V. So we're getting that individual div the first time through. Here is going to be 0, so it's going to be this first one, and we're going to find all the dot classes, which is going to be these two. It's going to find, and then we're going to loop through each of those, and that's where we set the background color equal to whatever the pattern is. And that's all there is to it. I mean, you could take and style it and go crazy. This is the basic functionality. We can go back, we can get rid of this and this. We can add a transition of 0.5 seconds. And that color is kind of hard to see. We can get rid of these numbers once we don't need those anymore. Or you can leave them on. You can populate every one of these so that you can get used to a binary clock. But let's change this. If we put this back to black, it's going to be one of those weird optical illusions that messes with you with like these corners. They're going to make you like see dots. So instead of that, we'll do RGBA, and we can do just any arbitrary number. And then we'll do the first time through I is going to be 0, so we don't want 0, we want I plus 1 times 0.25, and then plus that. Alright, so what that's going to do is we're going to give it an RGBA value, and we're only ever going to have 4 dots in a column. So I've just divided, the whole 0 to 1 opacity by 4, so 0.25. So the first time through here is going to be 1, and it's going to be 1 times 0.25, second time is 0.5, 0.75, and 1. Yeah, for some reason it doesn't want to be working because I've put I rather than index. There we go. Now if we want to change the color left to right, we can modify any of these. Let's just modify the green. And this time we'll do I, which is the columns. We'll do I plus 1, so it's not 0. And then times, and then we have 6 columns, so we can look at 255 divided by 6, so 42 roughly, so times 42. So now we have green going from basically 42 to 255 every 42 steps. So there's that. And then you could get a little bit more creative. You can add rotation. You can add all kinds of stuff, but this is the basics to getting a binary clock up and running. I'd love to see what you make with it, see your creativity. So post a comment, send a link, and don't forget to subscribe, as this is my new channel, and I look forward to doing many more tutorials across multiple languages and areas. So take care.